In this video, we're going to demonstrate 3D scanning some 2D patterns and creating a digital file for downstream applications such as CNC machining, laser cutting, water jet cutting, and other operations that require a digital file. In many industries, it's just cheaper, faster, and easier to create 2D patterns, or companies have legacy patterns laying around, and most modern machinery nowadays requires a digital file. So people need an easy way to turn these 2D patterns into a digital file, and we're going to walk through that process in this video. So our first step in the process is to set up a coordinate system. That way we can drop in a part, scan it, and have it in a coordinate system already, which makes everything easier, especially if you're going to be doing a lot of these patterns. So what we're doing here is setting up 3 planes, and there's many ways you can do this, but this is just what we thought of. We've set up 3 planes, the table and the 2 walls, and in this case we're using the Creaform GoScan Spark, and we're telling it to scan only the targets. So you see targets on the table and on the 2 planes, and we're just picking those up so we can set up this coordinate system and then easily place our part on the table, scan it, and when we output our data, it'll automatically be in this coordinate system every time. So we're only going to have to do this one time, and then we'll have it for as many patterns as we want to scan. Okay, so here is the data from the scanner. Now we are in the VX Element software that comes with the Creaform scanners. And you could do this with the GoScan, you could do this with the HandyScan, really doesn't matter. But we've only told it to scan the targets, and you can see I put the targets over here in an L shape just to indicate the left side. So that just helps us out. So here's the targets on the table, the front side and the left side. And we're going to use these targets to create some geometry to then create a coordinate system. And why that is important is that way when we drop a pattern on our table and line it up, it'll automatically be in a coordinate system. So if we were going to give it to a machinist or someone else, they don't have to try to set up that coordinate system. It just makes life easier. And you'll also see in a few minutes when we cut some sections, again, it's automatically going to be in the coordinate system. And we're only going to do this one time, and then we'll have it basically forever. So first thing we're going to do is come under Basic Entities and create a plane. And we are just going to use positioning targets, and I'm just going to window in on at least 3 of them. And it's good to kind of spread them out, and it's going to create that plane for us. So if you look here, you can see that plane. So let's go ahead and do another one over here on the front side and create that plane. Now you're going to notice the planes are kind of in a funny orientation. We don't really care about that. You'll see why here in a minute. And we're going to create our final plane here. And then the last thing I'm going to do is I'm going to create a point. And the point is going to be the intersection of those 3 planes. And that will basically become our origin. Okay? So if you take a look at this now and we put it in a kind of a side view and line it up, try to get this best we can, you can kind of see what that looks like. Same with if we did it in the top view. But right now our coordinate is still floating out in space because when you start scanning, there is no coordinate system. Okay, so let's go ahead and do a basic alignment, and we are going to do a plane line point. For our first plane, we're going to pick the bottom plane, and we're going to make that Z in the plus direction. Our second entity will be a line, and we're going to actually use the vector from plane 2, which is that front plane, and we will make that the Y positive direction. And then our point is going to be the point in the corner, which is going to set our origin, okay? So now we have set that up. So if we go into predefined views, you can see this plane here, this plane here. Let's go into another, like a side view, and same thing. So we've created this coordinate system. Now the next thing we're going to create is what's called a clipping plane. And what we're going to do is we're going to pick 3 targets, and we're going to do the same thing again. We're going to pick targets on the table. So we'll pick one here, Pick one here. And we're going to move it up. Let's go up about 2 millimeters and hit create. Now, what does this clipping plane do? It's basically going to clip off any scan data underneath it, because when we do the scanning of the pattern, we're going to also pick up the table, and that's just more data we have to work with and look at, and this is going to make it automatic. Now, the next step is I'm going to save this as a template, and again, I'll never have to do this again. So I come in here and I hit export, scan template, and I'm going to call this pattern template, and then we'll hit save. Okay, and that's it. So now we're all set to actually start our scanning process. Okay, so now we're ready to go ahead and do the scanning, and this is where the process would start from now on, because again, we've already set up that coordinate system. So we're putting our pattern on a table, we're lining it up with two lines that represent those two planes on the front and left side, and then we're going to also add a few targets with that we've put on some transparency film around the hole. And targets just work better because it tracks the part faster, it's more accurate. And we're loading in our scan template that we created. And again, this has that coordinate system, has that clipping plane. It's basically our starting point from now on. And then we just hit the scan button. We push the button on the scanner itself. And we're really just trying to get the edge of the pattern. And these patterns could be as thin as 1/8 of an inch, and the scanner will still pick it up and give us what we're going to need here in a minute, which is basically the profile. But you can see how fast the scanning is. I'm able to get all the way around this, and then I'm going to come over and scan the hole a little bit better. And I'm really just trying to get the edge of the part so we can get that profile. And that's it. We're done scanning. So you can scan very quickly. You could do a whole bunch of patterns at one time. And let's come in here and zoom in and take a look at our data. So you can see the quality of the data looks very good. So what we want to do next is actually create a profile, or basically a cross section through our part, so that we can export that. And how we're going to do that is we are going to leave VX elements and send this over to VX model. And what VX model is some add-on software for the Creaform product lineup, and it gives you a whole bunch of advanced mesh editing tools, curve tools, surfacing tools. And what we're going to use is some of these geometry creation tools, specifically the cross-section tool. So we're going to tell it we want to cut a cross-section, and we are going to pick the XY origin plane, and we're going to slide that up a little bit because it's right at the bottom of the table, and we'll just kind of move it up somewhere here in the middle, and you can see what that's going to do. It's going to cut a section all the way through our part, all the way around, as you see here. So we'll go ahead and take that, and we'll create a polyline, and we'll hit create. And if we go ahead and close that and take a look at our entity here and turn off our mesh, turn both of them off, you'll see we now have a 2D profile. And that profile is cut all the way through the part, continuous all the way around. Now, this is a polyline, which is just a multi-point line. And if that's all we need to work with, then our next step is very simple. We can just select here, and we can say export selected entity, and we can save it out as an IJustStep, CSV, or DXF model. Let's go ahead and save it as a DXF, and I'll just call this profile. And that file can go directly to some CNC machines, some different laser cutters, etc. So that's workflow number one, going directly out. But that is a polyline, and a polyline is just multiple points. Many people want to turn this into lines, arcs, splines, and they maybe want to make some corrections to it or changes to it. So that's going to be the second process here, and we can actually transfer it to a CAD system. So we have SolidWorks, Inventor, and Solid Edge as our options. I'm using SolidWorks, so I'm going to hit transfer to SolidWorks, and that's going to open up SolidWorks and bring this polyline in automatically, and then you'll see what I'm going to do next. So now that we're here in SolidWorks, what we're going to do is build geometry such as lines, arcs, splines, etc. And this also gives us the opportunity to make changes if we like. So let's start, and we're going to go in the sketch mode, and we're just using standard SolidWorks commands. We'll select our plane, and we'll start by building some line segments. And we're going to basically fit a line there. Now you'll notice here, this apparently looks crooked or has some bow to it. And this gives us the opportunity, if we want, to fit a straight line through it. So we're going to go through and do all basically the flat or the linear sections. Okay. And you'll notice I'm purposely staying away from the corners because the corners tend to get rounded off over time. And if I want a sharp corner, I'm just going to ignore them. Now, we've obviously got a lot of large fillets in here, so let's do those next. And we'll go to our fillet command, and we're going to pick 2 corners, and we're going to adjust the fillet size. And I'll just kind of toggle this and get to close to what I want. But you can see at 495, I'm going to say, well, that should be 5. So we can again override this. We can add dimensions if we want. We can basically constrain all of this geometry any way we'd like to. Okay, so let's come over here and pick our next set of geometry. And again, we can move it up or down, get it close. Again, 2.4. Let's make that 2.5. And hit OK. And our next one here. We'll go ahead and make that 2. And same thing here. We'll make that 2.25. So there's all of our fillets. Now let's go ahead and do our corners. And we're just going to use the trim entity command and trim those into sharp corners. Okay, and then the last step, let's go ahead and add our circle. And there we go. So now again, 1.59, I could change that to 1.675, whatever I want to do, I can override it. Okay, and let's go ahead and exit out. So if we now go ahead and hide that cross section, and let's go ahead and hide the plane, you can see what we have. So now we have lines, arcs, and for machining, this is going to give us circular interpolation. It's going to give us nice tangency. So we took the area out here that had some crookedness to it. We've made that nice and flat. We've got sharp corners. So in this process, it allows you to change it and turn it all to lines and arcs and splines and so forth. So once we're done, we can come under here and say Save As. And then we've got all kinds of file options here in SolidWorks. We can do Parasolid, IJust, Step. We can do, DXF, DWG, a whole host of formats. We'll call this DXF. We'll just call this pattern 1 and save it. So that's the whole process right there to go from the scan data into a profile that's usable for downstream applications.